Okay, we want to talk a bit more about microcontroller timers in this lecture. We're going to build on what we did last time. Remember that in lecture 10a, we created a 1 millisecond time delay using timer 1. We preset the hardware so it would generate a flag after 1 millisecond, and we polled for that flag. So then we could take action after 1 millisecond. Today we want to expand all that and functionalize some of what we did so far to make it more useful so we can actually replace the standard delay function. Because remember that in the standard delay function, we just write a number. We say delay ms, we write a number, and it waits for that long. This is very specialized to just our microcontroller system. So the hardware technique that we discussed last time and that we'll expand on works across many different hardware platforms and has some more universal timer usage in it. So just a quick review, you guys remember from C programming, functions are building blocks of our code, right? We can make a function, nest a piece of code in it, and then call that same part of the code, or call that chunk of code in the function over and over and over to eliminate redundant code, make things easier to read. We can then create libraries. We can move functions between one C file and another a lot easier. And so this allows software to be modularized. So putting like function blocks in a module. So if you created your own timer in its own .c, timer.c file, you can take this module to other programs that you build and reuse your timer without having to recode it everywhere. So back to what we did last time, we just want to highlight that we are creating this 1 millisecond delay function. And the last video talked about the specifics of setting up the timer to do that. Today, we want to make our function delay underscore 1ms that does what we defined last time. So remember that when we make a function, we have two parts to it. One is our function prototype. This goes up above our int main, up at the top of our file. This is where we define the name of the function so that we can use it in our code and we won't get errors. And then we actually define the function itself and the code that's in it later on in our file or in a completely separate file. But a function prototype, as shown right here, must be included at the very top or before we can use that function. Then we have the actual definition of the function itself has to be somewhere. And then to use the function, a function call looks like what just appeared. So if we want to call a function, use a function, and run the code that's in it, we just say the name of the function with parentheses at the end. If there are any arguments to that function, they go in the parentheses. So note that in your function prototype, you define the type in multiple ways. First, the first void is the type of the function. That's the type that you will be returning. If you're not returning any value, void is appropriate. If you are returning something, it may be an int, for example. And then in the brackets, that type is the type of the argument. So if there are no arguments being sent to that function, for example, our delay 1ms has no arguments, it just sets up the timer and does a 1 millisecond delay, the arguments are void in this case. And remember and watch the previous video to see this flowchart in more detail and how we generated the code. But for our function, delay 1ms, we want to preload the timer, set the desired clock frequency, wait until the clock overflows, so it reaches the value we set it to, up to its maximum. It takes 1 millisecond to do that. Then we stop the timer, clear the overflow flag, and then return. So that's all that's happening in this function that you see before you now. And this is the code that we made last time. This code is your 1 millisecond delay. We've just placed it into a function. So instead of writing all that code, we can just say delay underscore 1ms, and it will run that delay. So what if we need more than just 1 millisecond? Which, spoiler alert, does happen quite frequently. We need more than just a 1 millisecond delay. And you guys have seen in our pre-made delay function that we frequently use multiple of 1 millisecond delay. So to do that, here's a flowchart representation. We set a loop counter to 0. Is the loop counter less than the desired number of milliseconds? If it is, we'll run the delay 1 millisecond one time, and then we'll increment the counter and check it again. So coding-wise, our counter for the amount of milliseconds this function is going to run starts at 0, and you see the counter equals 0. Once we delay 1 millisecond, we increment it. So counter plus plus means we've delayed 1 millisecond. To actually create that delay, we just call our function. And then a for loop can do this counting for us. We just count from counter equals 0 up to the number of milliseconds that we want. And so this is what that would actually look like in a new function called msDelay. Notice that it has an input argument this time, the uint16 time. The uint16 matches the size of our counter, counter 1 that we're using. If it was an 8-bit counter, we would need a uint8 here. But we're using timer 1, which is a 16-bit counter. So that flowchart is being executed within this function. The counter is created, and then the for loop has counter go from 0 up to the number of milliseconds that the user specified, and delays 1 millisecond, and then increments the counter by 1. So this will count a certain number of, the time is the variable, number of milliseconds. So that's how many times you're going to run your 1 millisecond code covered in this function. So again, to use this function, you could just say ms_delay with a for, and that would delay for 4 milliseconds. This function, however, needs to have a prototype up at the top of your file. In fact, all functions do, whether it's defined at the top of your main.c file or you have a separate file. We've used that serial.c in the past. We'll use separate files in the future so we can modularize our code. But you must have a function prototype somewhere to define to the compiler that that function exists. So that is how we would nest our 1 millisecond delay into another function to give us a variable millisecond delay. So your worksheet this week is going to have you explore some of those concepts of the timer in more detail, possibly with the use of the AVR 2560, the Atmel 2560 datasheet. So look to do that. And I will talk to you again next week.